Hello everyone, this is Arohi and welcome back to my channel Code with Arohi. So in my today's video, I'll show you how to implement Yolov5 on custom dataset. So the dataset which I'm going to use for today's example is traffic sign detection dataset, and this dataset have, let me show you the dataset. So basically in this dataset, we have four different classes, right? So this is the dataset looks like, right? Image and the related text file. This is how Yolo accepts your data, right? So the image and the related text file, and when you'll open this text file, so first of all you'll get the class name, and these are the four bounding box coordinates. So this is how Yolo model accepts data in this format. For every image we need one text file. Okay, so this is the data which I'm using, traffic sign detection, and this dataset have four classes, and let me show you the classes which we have in this particular dataset. So let me open the file. So these are the four classes: speed limit, yield, and mandatory, and others. So these are the four classes we have in this particular dataset. So now what we want is, let's come to this coding part. Now first of all, what I've done is I'm using TensorFlow 2.3.1 for this example for Yolov5, and I have installed TensorBoard 2.4.1. okay, and after that we are installing this PyTorch. So why we are installing this PyTorch? Because Yolov5 works on the top of PyTorch, so we need to import this module inside our Jupyter notebook. So that's why I'm importing it. So I have installed PyTorch, and in next line over here I'm importing this PyTorch module. Now after that, in this particular line, what we are doing is we are importing this display module from IPython, because we are using this module to display our results, to display the outputs images. Okay, so that's why we are importing this module. Now the next, in this line over here, you can see I have commented this section because I have already downloaded this particular GitHub repository. But when you want to work on Yolov5, first of all you need to clone this GitHub repository. Now this is the link. Okay, GitHub Ultralytics. Now why we are downloading this Yolov5 repository from here? Because they are the developers who developed Yolov5. We will download their repository from here. When you will visit this page from here, you can come over here and you can download the code from here, whole repository from here. Once you download this whole repository, after that this is this kind of folder you will see. So what I've done is, so this is my project folder. Just create one project folder in which you want to work, and under that this is the file, which Jupyter notebook, which I'm showing you, in which I'm working. Okay, so in this Jupyter notebook I have written that I want to clone this particular GitHub repository. What that means is, when you will execute this command, after that you will have this Yolov5 folder inside your current working directory folder, and when you will open this folder, you will see lots of different files and folders over here. I'll explain you what these files are and why we are how we are going to use them. But right now just understand, after cloning that, you will get this folder, and inside this folder you will be having multiple files and folders. Okay, all right. So now once you clone this folder, next step is we are entering inside the Yolov5 folder, which we have just downloaded from internet. Okay, and in that we have one requirement.txt file. We are installing all the requirements. So when you will open this Yolov5, you will see over here we have requirements.txt file. So we need the required software, so that's why we are running it. Okay, after that, now the thing is, now we will prepare the data in the format which Yolov5 accepts. So let me go back to the folder where we have our data set. So initially our data is in this data folder. Okay, So this TS folder. So we have all the images and their related text files over here, right? But what we have to do is we have to divide our data into train and test. So what we have done is, okay, so what I've done is, what I want is, I have created another folder with the name of dataset, and under that dataset folder we have one folder with the name of images and one folder with the name of labels. So inside images we have two folders, train and validation. Okay, in the same way under labels also we have two folders, train and validation. Okay, so inside images what we want is, from this data folder where we have all our images and their related text files together at one place, we want to split this data into train and validation. And what we are doing is, for images we have created separate train and validation folder, and for labels we have created separate train and validation folder. Okay, so now we'll write a code, write a function. Using that function we can divide the data of this data folder in the images. Under train you will see the only images which are related to training, which are got splitted into training, and under validation folder you will see all the images which we have in a validation folder. Okay, so let me show you the function which I'm using for this. So what I've done is, so first of all I have created two blank lists. This images list will store all the images, and this XMLS list will store all the text files. And these are the three paths. So what is the path? CRS path simply means the folder where we have our data which we want to divide into the train and split. Okay, so this is the path of that folder, and over here this is the path of images train folder, and this is the path of validation folder for images. Okay, now I have two variables, train ratio 0.8. so what I'm trying to say over here is that I want 80% of the data. So 0.8 simply means 80%. So what I want is, I want to out of this total data I want to put 80% data in a train folder and 20% data for validation. So that's why validation ratio is 0.2, which is 20%, and train ratio is 80%. Now over here you can see I'm using this code, and what I'm doing is I'm storing all the text files over here and all the images over here. Okay, I'm appending that list, and all the images I'm storing in imgs list, and all the text file I'm storing in over here. Okay, so you can see over here the blank list which we have created above. Now next thing is, okay, so over here we are just printing how many images are there in training, for training, and how many images are there for validation. Now what we want is, we want to put the data into a train and validation folder of images and for labels also. So this train image path is having the path of train inside the images, and same train label path simply means the path of label, for training, and the same way path for validation images and path for validation labels. Okay, so now we have two loops. One loop is this and another loop is this. So first loop is moving, this first loop is moving this we are using copy over here. So what we are doing over here is, we are copying the data which is present at this CRS path, our main this is the path where our data set is, right? So we are copying the data from here and count for train. So what is there in count for train? This is the 592 images are there for training. So what we are doing is, we are using this loop and we are copying the data into the train image path. What is there in train image path? The path which is related to images which we are going to use for training. And in the same way, train label path, this is the train label path, and we want to store the related labels of those training images inside a train folder which is inside labels. So in the same way, we have performed the loop for validation also. So these two functions, these two loops, we have simply used that just because what we want is, we want to divide our data set into train and val, and this is the train now. So you can see inside train we have images, and when you go under labels, and under labels you'll check train, you will get the related text files over here. In the same way you'll see for validation. Okay, and one more thing, see, when you want to work for Yolov5, so this is the very important file which you need, which is dataset.yml. So when you open this file, you can see what is there in this file. First of all, inside this train, you need to give the path of your training images, and inside this val, you need to give the path of your validation images, right? So my images are present in dataset, under images, under train. So see, dataset, under dataset I have images, under images my training images are in training folder, and validation images are in val folder. So this is the path you have to mention. NC, these are the number of classes. So as I've just told you, like in this dataset, we are going to detect 4 different classes of traffic signs. So that's why I've written the number of classes. And over here in this list, you need to define the name of those classes which you want to use in this. So these are the 4 classes which we are using. So this file is very important. Okay. So dataset.yaml. So this is new in Yolov5. In Yolo version 3 or Yolo version 4, we work in a different way. So this particular file is new in Yolov5. Okay. So now we have images, labels, and dataset.yml file. Now our dataset is ready. Now we can run our Yolov5 on this. So let's go back to our Jupyter notebook. So we were over here, right? So I've already explained you how to create this file. Now next line is this training. What we are doing is Python train.py. So where is this train.py? So we are working inside this Yolov5 now. Okay, so over here you can see we have train.py file. So this file is responsible to train your algorithm on your data. Okay, so what we are saying is Python train.py image 415 means this is the size of the image, batch 16 batches, epochs we want to do the training for 30 epochs, and dataset.yml. So this dataset.yml means this file. So from this file your algorithm will see where your data is, right? So see, when you are writing this dataset.yml, your algorithm, this training file will see, okay, this is the data, training data is present here and validation data is present here, and number of classes are 4, and these are the name of the classes. So from here it is, getting the information about your data set on which you want to perform the training. And then weights Yolov5 S. S means we are using now these are the pre-trained weights. So initially we are starting our training on the pre-trained weights. So we are using this Yolov5 s.pt. This file you will get when you clone this GitHub repository. Under that you will get this weight file by default. Okay, so we are using that weight file. So this is the command which you have to run, and this will take some time, right? According to your machine configuration, it will take some time to get proper training. And now let me show you where you will see the results after training. So under this Yolov5 only, you have one folder with the name of runs. Open this runs folder. So initially, so I have already performed the training and the test, so that's why I'm having detect folder over here. But initially, when you'll download this GitHub repository, right, you will only get this train folder. Okay, inside this train folder, these are the folders which will get created. You will get folder over here. So now my code is in this, the output results. Open this. So you can see, you will see one weights folder under it. So when your training will get completed, under weight folder, you will see two weight files. One is best.pt, other one is last.pt. We will always use best.pt. Okay. And over here you can see all these files I'm getting here after the training. Okay, so these are the different results which we are getting after the training. Let me show you one by one what all these files are. First of all, let's open this result.txt. This. So this is the file which is, storing your, let me open it first. So this is the file. See, this file started, for every epoch it stores the different information, like how much is the loss, how much is accuracy, all those things all those things are getting stored in this results.txt file. Okay, so by default this is the file name. So when your training get completed, inside this runs, you will have train folder. Under this train folder, you will have one folder with the name of, if you are running this code one time, then you will get folder with the name of exp, and if you are running this code second time, you will get folder with the name of exp2. And in the same way, if you'll run the same code again, then, and this exp folder and exp2 folder is already there, then new folder will get created with the name of exp3. Okay, so clear about the result. This will store all the results. Now after that, let me show you the predictions. So you can see these are the batch. These all images belongs to one batch, right? And you can see our algorithm is predicting the results, and this is the next batch, and these are the predictions related to it. So all these results will get stored itself only, right? And these are the test images on which I want to perform the test. I'll show you in some time what is this, right? So just right now, just remember, you will get all these curves. Speed limit, so these are the different classes, and these are their confidence and precision calculation. And you can see recall, right? And these are the details. If you want to see box wise, objectness, you'll get all the you'll get all these graphs over here, right? And these all things will get created itself only. All right, so now once training is completed, so this is the line for training. Once your training get completed, now what we want is, we want to test our algorithm. So basically, okay, these two lines are just, let's suppose if you want to see all those graphs over here, then you can write these two lines and you can see the results over here. Now let me show you how to test your model. So okay, what I'm doing over here is, before testing my model, what I'm doing over here is, the images which are present in run, under train, under exp2, I have just shown you, like, right, these are the images which belongs to one batch, and we are just plotting those images just to let, in case if you want to show those images on the this Jupyter notebook. Now over here, what I'm doing is, I'm making the prediction, and for prediction we have detect.py file. Where this file is, just go to this Yolo5 folder, and over here you can see we have one detect.py file. Okay, so this file, we will use this file to detect the objects. So over here what we are using is, we are using this file, and source simply means on which particular image you want to do the detection, or the video you want to do the detection. So this is the path. So I have an image with the name of a.jpg, which is present in this folder. Okay, let me show you this image. Under runs, train, exp2. So we have one image with the name of A. This is the image. Okay, this is the image. In this image I want to perform object detection. So, and over here which weights we are using is the weights which we get after training our algorithm, right? So if you remember, under this weights folder I've told you like you will get two weight files and we will use best.pt files, right? So we are using best.pt. Why we are using this weight file? Because what we want is we trained our algorithm on traffic sign detection dataset, and what we want to do is we want to detect the different traffic signs, and all those weights are algorithm. After training our algorithm we have this particular file which will help us for detecting the objects. So we are doing that. When you'll run this, okay, after this you can see over here results saved to run detect exp4. When you run this file, after running this file you will get a detect folder where, so you will get this detect folder when you run this particular file. Okay, so inside this detect file it is saying you have exp4 folder. In that exp4 folder we will see the results. Now you can open the file and you can see our algorithm is detecting the objects, right? So this is how this Yolo5 works, right? Very simple. So what you need to do is just a quick go through. Just download this Yolo5 from here and prepare your dataset in the format which Yolo5 accepts. How Yolo5 accepts the data? Yolo5 accepts the data under images. You have to create train and val folder. Under labels also you have to create train and val folder, and we will store data in this folder by the function which I've shown you, and this is how you can run the function. So guys, I hope you like the video, and guys if you like the video please subscribe my channel, and thank you for watching.